Hello friends, I am Dr. Himani Garg, working as professor in Department of Electronics and Communication Engineering in Akgec Garg Engineering College, Ghaziabad. Today I am going to discuss about the topic amplitude modulation. I hope that you are clear about the basic blocks of communication system in which we have a message signal and we have to transmit that signal from a channel to a receiver. In this communication system, modulation plays a very important part. There are different types of modulation. That can be continuous wave modulation or pulse modulation. And when we talk about continuous wave modulation, it is further divided into amplitude modulation and angle modulation. Now in angle modulation, we can talk about frequency modulation and phase modulation. In pulse modulation, it is divided into digital modulation and analog. Under digital comes pulse chord modulation, or that can be delta modulation. And in analog modulation, there can be pulse amplitude modulation, pulse width modulation, or pulse position modulation. So in this whole chart of modulation, today we will be discussing about amplitude modulation, that is the basic modulation, and it comes under continuous wave modulation. Now, what we mean by amplitude modulation? It is the process in which amplitude of the carrier wave is varied according to the message signal, that is the modulating signal. Now in modulation, two types of signals are there. One is the message signal, or the signal that we want to transmit, and another signal that is called carrier signal. Why it is called carrier? Because it will be carrying our message signal, so that is why it is called carrier. Message is always a low frequency signal and carrier is always a high frequency signal. As we know that length of the antenna depends upon lambda by 4, length of the antenna depends upon lambda by 4. Now if the frequency is, and it is equal to C by F into 4. Now if the frequency is high, then the length of antenna that will be less. So that's why we take the carrier as a high frequency signal. So in the process of amplitude modulation, the frequency and the phase of the carrier wave remains constant. In a signal, we are having amplitude, frequency and phase. In the case of amplitude modulation, only the amplitude of the carrier is varied. The phase and frequency of the signal, carrier signal, remains constant. Now, as you can see in this diagram, we are having three signals. One is the message signal. This is the message signal, that is the signal that we want to transmit. This is as, for example, I am speaking and this is my voice signal, and it will be acting as the message signal. And if I want to transmit this signal to a longer distance, then this message will be carried by a carrier signal. This is called carrier. As you see, the difference between the message and the carrier is, message is a low frequency signal and carrier is a high frequency signal. Now in this carrier, the amplitude is denoted as AC, and in the modulating signal, the amplitude is denoted as AM. For message signal, the amplitude is A of M, and for carrier, the amplitude is AC. Now how the amplitude modulated wave will look like? Now you can see this is the frequency of this signal. See these red pulses here, this red waveform. In this red waveform, the frequency is equivalent to that is following the amplitude of the message signal. So the amplitude of the carrier is being modulated on the basis of amplitude of message signal. That's why it is called amplitude modulated wave. Now in this modulated waveform, the amplitude will be AM plus AC, that is the addition of message amplitude plus carrier amplitude. So all the instantaneous values of the modulated signal will be a combination of message plus modulating signal. You can see this one is this point shows the minimum amplitude, this one is the maximum one, and this blue line shows the envelope of the signal. So this is the amplitude modulated wave. Now we will be discussing about this modulated waveform. Now, the important thing is to derive the general expression of this waveform. In amplitude modulation, the message signal, here the message signal is denoted by MT, is impressed on the amplitude of the carrier signal. Now, students, we will see, you can see here the carrier signal is denoted by C of t because it is varying with respect to time. Now, the signal is denoted as AC cos 2 pi FCT. The amplitude here is, the peak amplitude of the carrier is AC. The angular frequency of carrier is omega c and Fc is the carrier frequency. So this carrier signal is having the maximum amplitude as AC. Now, as in amplitude modulation, we will be talking about the change in amplitude of the carrier according to the amplitude of message signal. So we will be working on this amplitude of the carrier. Now, when we talk about the message signal, message simply denoted by m of t, and that is given by am cos omega mt. 2 pi cos omega, this can also be written as omega c. This can be written as omega c. Omega c can be there, AC cos omega ct or 2 pi fct. Now, in the case of message signal, am cos omega mt, where am is the peak amplitude of the baseband signal. Before modulation, we will be calling this signal as baseband signal. Omega m is the angular frequency of the modulating signal. That's why it is written as omega m. Fm is the modulating signal frequency. This omega is the angular frequency and Fm is the modulating signal frequency. So this is the message signal. This results in a sinusoidal signal modulated. The combination of both these signals whose amplitude is a function of message signal m of t. So the message signal will be modulating the carrier according to the amplitude of the message signal. So as per the definition of AM, we are required to change amplitude of the carrier. In the last slide, we had seen that the carrier signal is denoted by AC cos omega ct, where AC is the amplitude of the carrier. Now, what will be the amplitude of the modulated signal? That will be equal to AC, that this amplitude will be there, AC, the amplitude of the carrier will remain, plus m of t, where m of t was the message signal. Now, as the message signal is not continuous and it is varying constantly, we had seen am cos omega mt. So the instantaneous amplitude of the modulated signal will be carrier amplitude plus instantaneous message signal, and it will be, what will be the frequency? Frequency of this signal is equal to the frequency of the carrier. That's why you can see here, this is cos omega ct, because we are making changes in the amplitude of the carrier signal. So ultimately the carrier signal frequency will remain the same, where AC plus m of t is the amplitude of the modulated carrier and is called the envelope of the modulated carrier. Now, we will put the value of message signal here. In the last slide, we have seen that message signal is equal to am cos omega mt. So, we have put the value AC m of t, we have written here as am cos omega mt, and cos omega ct remains the same. Now, when we will open it, it will be AC cos omega ct and then am cos omega mt into cos omega ct. So this will be the equation after opening this bracket. Now we will again solve this equation. The amplitude modulated, we will use the identity here. We will be multiplying it by 2 and dividing it by 2. Then ultimately AC cos, we will be left with AC cos omega ct. It will remain same. Now this 2 and 2, this 2 will go here, and ultimately we are having am by 2. This is under am by 2. You are having am by 2, 2 cos omega m cos omega ct, and we know that cos a cos b is equal to cos a plus b plus cos a minus b. So we have used the trigonometric identity here, AC cos omega ct into am by 2, this will remain, and 2 cos omega a omega mt, that we can say a, and this is b, that is equal to a plus b and A minus P. So ultimately we are having this equation. Now in this we are multiplying and dividing this signal by AC by AC. Okay, we are dividing and multiplying it by AC and AC. So the other equation will remain same. Now you can see here we have changed this AC we have kept it here and kept AM by AC, the ratio of AM by AC here. Other equation will remain same. Now the first equation will be same. Now this AC by 2, that will remain same. Now AM by AC, that has been noted by MA, that is called the modulation index. This is called modulation index. So AC MA by 2 cos omega CM plus all the other equation will remain same. So this is the final equation for the amplitude modulated wave, where we are having the carrier. This is the carrier part, and this is the carrier plus message, carrier minus message part, right? So you can see here we have shown these equations in this form: AC cos omega CT, AC MA cos omega C, and the same terms. So this term is called carrier. This frequency FC plus FM. When you add on frequency, we are having a frequency FC, and another frequency is FC plus FM, another is FC minus FM. So we are having 3 frequencies. This FC plus FM will be called as upper sideband, and FC minus FM will be called lower sideband. So our modulated signal comprises of 3 terms. One is the carrier, another is the upper sideband, another is the lower sideband. So this is the amplitude modulated waveform. So you can see the signal here, the amplitude modulated waveform. Now I have shown you the description of this modulated waveform. Now you can see here in this diagram, in this particular part, there is no modulation has taken place. So what will be transmitted? The carrier will be transmitted. So the amplitude of the carrier is, the maximum amplitude here is Vc. So therefore for this particular portion the carrier is being transmitted. After that we are having the message, that is message is changing the amplitude of the carrier according to the message signal. So you are having ultimately the message signal will be Vc plus Vm sin omega mt or cos omega mt. That is the same thing. Earlier we have discussed about cos omega mt. Here we can talk about sin omega mt. So Vc plus Vm sin omega mt. So this is the carrier, and in the lower trough will be, this is plus 1, this will be minus Vc plus Vm sin omega mt. In this part will be the maximum Vm, and this one is the minimum part Vm. This is the minimum part. Okay, so this is the amplitude modulated waveform. Now when we talk about the various forms of amplitude modulation, from this equation we can have different types of modulation. These are conventional amplitude modulation known as full AM. Full AM means we are having, or double-sided FM, double-sided full carrier modulation, in which includes all the 3 terms: carrier, upper sideband and lower sideband. Next is double sideband suppressed carrier modulation. Now in the upcoming videos we will see that if you are using or sending all the signals together, the 3 terms together, then it will decrease the efficiency of the system. That's why we are having different types of modulation in which we can suppress the carrier. As both the sidebands will include the same information, then we can remove one of the sideband. So on the basis of that we can have double sideband suppressed carrier, DSB-SC, in which we will be having both upper sideband, lower sideband, and there will be no carrier. There will be no carrier. Single sideband modulation. In single sideband modulation, there will be only one sideband will be transmitted. That can be upper sideband or that can be lower sideband. Now the fourth one is the vestigial sideband. When we are sending a single sideband, then there is a possibility that some of the signal can be lost. So in that case we are using vestigial sideband, in which we will be sending some part of the upper sideband along with lower sideband. In the case of picture transmission, that is generally used for picture transmission, that is called vestigial sideband modulation. So these are my references. I hope you will be able to understand the amplitude modulation through this video. Thanks for watching the video.